Hello everyone, this is another video in which I am going to solve a problem subarray with zero sum. This is very specific to the problem which I have solved in my previous video, which you can check inside the I button or inside the description. That was the problem for subarray with sum k. This is just a specific version of that particular problem with a specific value for k equal to 0. So this particular problem I have taken in order to have a strong grasp on the logic of prefix sum plus hashing approach. Now firstly let's read the problem statement what it says. The problem statement says is that we are given with an integer array nums of size n, and our task is to determine whether there exists at least one subarray whose sum is equal to 0. And we have to return true if such a subarray exists, and we have to return false otherwise if any of the subarray does not exist with the sum 0. So the problem simply says is we are given with an input array, and we have to just return true if we find any one of the, like, at least one subarray also with the sum 0. So we need not to check for the number of subarrays which are giving the sum 0. We just need to check for the first occurrence of the subarray. If it gives the sum 0, then we can return true in that case. But after checking all the subarrays, if they are not having any of the subarrays with sum 0, so we can return false in that case at the end. So this is the problem statement. And now checking about the approaches, like what approaches we can use in order to solve this problem. So like in the previous videos also, for the same pattern problem, I have used the different approaches. Like firstly the brute force, then I moved towards the prefix sum plus hashing, then to the sliding window. So they were based on the input constraints, that how the constraints are defined. So for a particular problem statement, if the input constraints are like the positives, negatives, zeros, all are present inside the input, so in that case we cannot use the sliding window, because for negatives sliding window fails. Like it is only a optimal solution for the space optimization technique, a kind of a space optimization technique which can be used when only positives or zeros are present inside the input. So if negatives are there, we cannot talk about the sliding window here. So now firstly getting started with the very brute force, the naive approach, in which I have told that we can check for all the possibilities of subarrays with the help of two loops, which I have also explained in my previous video. You can check there. It is taking big O of n square time complexity, means it is too slow because of the recomputation of the sums again and again. We will not be discussing it here, as I have already discussed. We have to just check for the sum 0. There we were checking for some k, and this is only for the specific value for the k equal to 0. That is similar to that, and the time complexity is big O of n square, and space complexity is constant for this. Now just moving towards some better approach in order to solve this. So this is one and only the prefix sum plus hashing approach. So let's firstly discuss it, what it is. I have already explained, but again, in order to have a strong understanding, I will be explaining it here in detail as well. Okay, so now let's get here, and let me explain firstly what it is. For example, we are having a particular array, and we have to apply this particular approach, prefix sum plus hashing approach. How we do that? This is an input array. What we do is, in order to reduce the recomputations of the sum again and again, we just start from the 0 index and go till end index, and one by one we just start to take the cumulative sum, or I can call it as a prefix sum. Like the sum is taken from the previous indices, and it is accumulated till this current index. And at any particular index, at any current index, if we are having a prefix sum, then we can say, right now, for example, if I am standing at this fourth index, I am standing right now at this fourth index, so I can say, till now I am having this prefix sum. Till now I am having this prefix sum, and I can say if now I am at this fourth index, so I can check for all the subarrays which are ending at this index. Okay, for example, for this particular fourth index, the subarrays which are possible, these can be from 0 to 4, from 1 to 4, from 2 to 4, 3 to 4, and for this fourth index only. So these are the possible subarrays which I can check for the sum 0. Now I cannot look for any of the index, like beyond this particular index, for any of the subarray. I am just having the control over these subarrays, from which I can find any subarray with sum 0. For a while, just consider that any of the subarray out of these, just one subarray I am assuming that this is a subarray which is going to give me the sum 0. I am just assuming it. Just for the sake of understanding, let me give it as k equal to 0, but it is just specific for the value 0. This is k equal to 0 with the subarray giving the sum 0. Now if this particular subarray is giving me some 0, then for sure, because till from 0 to till this index, fourth index, this is the prefix sum, and this subarray is going to give me the sum 0, then this particular part, 0 to 1 index, it is going to give me prefix sum minus key. It is going to give me prefix sum minus key. That is very understandable here. Till now this is complete prefix sum, and if this part is completely zero, then or I can say it is key, then this is going to be prefix sum minus key. But because we are solving this particular problem for k equal to 0 for the subarray sum 0, so minus k makes no change. It is going to remain the prefix sum. So I can say in this way that if prefix that this will be a prefix sum. Okay, so now let me just reverse it. If I am saying till this particular index, I have if I have checked the prefix sum, so this is the prefix sum till this particular index, and I'm just saying that if I have found the same prefix sum earlier in the past at a particular index, then for sure after that particular index till this current index, something has been happened which has balanced out some the things, which had cancelled the things, and resulted in order to give the sum 0. So I can say from here that till here this is the prefix sum. I have encountered the same prefix sum till this one index. Therefore, this entire subarray is going to give me the sum 0, because nothing has been changed yet. They had all been cancelled out, and the same prefix sum has been carried till this index as well. So this is the whole intuition behind it. So what we can say is just we have to check one condition, that at every particular index, if we are finding the prefix sum, and just we have to check if this same prefix sum has been encountered earlier or in the past, then I can say that yes, this particular subarray means where that same prefix sum was encountered from that index plus 1 till this current index is the subarray with sum 0. This is the whole logic behind it. Now let's get into the input, the example which I have taken, and let's perform a dry run on it. So this is the example I have taken, and let's just perform a dry run. Now what we have to do is we have to basically just check for the prefix sums. Okay, so that we will have to store somewhere in order to check if it exists in the past or not. So in this particular problem, we need not to store something like the frequency or some or the indexes. We do not have to do this. We just have to check for the existence and then return true. So there is no point of using the unordered map or the map here, because we need not to use the we need not to store the two parameters. We just have to store the prefix sum. So for this we can use the set. Okay, and in the set also, if we have to have the better time complexity, then we can use unordered set in that case. Let me just take the unordered set here, and let me just name it as set. And now based on the logic, based on the approach, I will be just taking the prefix sum here, so that I can just add every time. Prefix sum I have initialized as 0. I am taking this I index which is pointing at 0. Now firstly I is pointing at 0, so 4 will be taken and added inside the, we can add inside the prefix sum. Now it became 4, and now we have to check for prefix sum. Means as we were doing in the previous problem, like prefix sum minus k. So here the k is 0 itself, so we can just say we have to check for prefix sum itself we have encountered. So now we can see here that prefix sum means 4. It was not seen in the set before. So what we have to do is we just have to go and inside the set and insert it. 4 will be coming in the set and we will insert it here. 4 will come here and we have inserted it. Now I will move ahead. When I moves ahead, it sees 2. So when 2 is coming, the 2 will be added in this. 4 plus 2 will be 6. And now we will be checking for 6 if we have encountered in the set or not. So 6 is not found in the set. So now 6 will be also inserted inside the set. Now I will move ahead. Now minus 3 will be added inside the prefix sum. So 6 minus 3 will be 3. And now we will be checking for 3 in the set. So 3 is also not found in the set. So we will also be putting this particular 3 inside the set. And then I will be moving ahead, and it has seen 1. So now 1 will be added inside prefix. So it becomes 4. And when we see in the set that we have found 4 or not, so yes, 4 has been found in the set. Now let me just explain what is happening here. At this current index 3, we have checked this is the particular prefix sum till now, and we have seen this 4 before as well, and that we can see from the set itself. 4 has been seen, and we can see in the array till at this particular 0 index. It means because prefix sum was 4, and till this 3 index prefix sum is also 4, therefore the prefix sum has not been changed after 0 index, because after 0 index, from this 1 to 3 index, this particular things were cancelled out or balanced out in order to give the result 0. So 2 minus 3 minus 1 plus 1 0. This particular subarray is giving me the sum 0. Okay. By this, uh, what I mean to say is, if this particular prefix sum has been encountered, same prefix sum at the 0 index as well, therefore one subarray is there which is having the sum subarray sum 0, and because I have seen in the set as well it is encountered, therefore I can just return true. Now I need not to do anything here. I can just return true in that case. I need not to check for the another subarrays with the sum 0. Okay, because I was just assigned with the task in order to return true if I have found at least one subarray with sum 0. So I have found this subarray with sum 0, so I will just return true. And if in just a case if it happens that I have not found any of the subarray with sum 0, I have not found in the set of any of the prefix sum to be encountered, at the end after completing this array I will be just returning false in that case. In this case we are getting the subarray with sum 0, so I can just return true here. Now this is one thing. Now if I take one another example, let's say, let me just copy it from here and let me just another example. This is the example, and let me just give the values here. Let's say -1 is here, 1 is here, the -2 is here, the 1 is here. These are the axes for this. And now let me just explain one particular case which I have already explained in the previous video, but it is missing I think in this particular example. That's why I have taken this. Now if I give this text, I am pointing this I at 0 index, and now taking the prefix sum. So prefix sum for initially was 0. Initially the prefix sum was 0, and now when I is pointing at 0 index, firstly it will become 1. Okay, it became 1 now. Okay, so we will be having the set in this as well. Let me just copy it from it here. Initially nothing is there inside the set, so I will be just adding this particular 1 inside this set. So 1 will be added, and now I will move ahead. When I moves ahead, -2 will be added inside this prefix sum, and it becomes 1 minus 2, that is -1. And -1 is also not seen in the set, so minus one will also be added inside the set. Now I moves ahead and it sees 1, so now 1 will be added inside this and it will become 0. So now this prefix sum becomes 0, and now we see in the set that we have seen 0 in the set or not. So we have not seen. Now this is the case which I have to talk about. Initially the prefix sum was 0. Initially the prefix sum was 0, and that was the kind of virtual prefix sum when we have not started taking the sum from the array, when we have not yet started with the 0 index even. So at that point of time the prefix sum was 0. That is a kind of virtual prefix sum. So we can say, okay, so now when 0 is present here, and now we are checking for the 0 in the inside the set, so we are not getting the 0. But based on the logic, we are just asking that has this particular 0 been encountered earlier? So yes, 0 has been encountered earlier. That was when we have not started taking the sum, when no elements were added inside the prefix sum. So at that point of time the prefix sum was 0 as a virtual prefix sum, and that thing we must insert inside the set in order to avoid the missing of the valid subarrays which are starting from the 0 index. So if any of the subarray, in this case we can see that 1 minus 2 minus 1 plus 1 0, this is a subarray with the sum 0, which is a valid subarray which is starting from 0 index. So in order to avoid missing of these particular valid subarrays, we have to insert this 0, the virtual prefix sum, inside the set before starting any of the taking the sum, any of the cumulative sum or prefix sum. So firstly we will have to insert this 0 here, and then we can start, and this will just give us the valid subarrays which are starting from 0 index. So now we ask that prefix sum is now 0, and have we encountered 0 earlier? So yes, we have encountered when we have started taking the sum, and that is present inside the set as we have inserted before. So now it is encountered, therefore I can just return true because now I am having the subarray with 0 sum. Therefore this case is also have checked, and now let's get into the implementation part. So here firstly I will be taking the unordered set, and one parameter will be here along that will be the value, the prefix sum which we will be inserting inside the map. And let me just name it as set. And now inside the set, as I have just explained, we'll have to insert true at the start in order to avoid the missing of valid subarrays starting from zero index. So we have inserted 0, and now I will be taking the prefix sum variable in order to have the sum inside this. Currently initialized as 0, and let me just use for auto val. Every value will be taken from the sums, and now I will be just adding inside the prefix sum. So one value is taken from the sums array and added inside the prefix sum. Now after adding this, I will have to check inside the set that if this particular prefix sum has been encountered earlier or not, the same prefix sum. For that, I will be using the find function inside the set and check for the prefix sum. And as I have just done condition many times, very understandable, uh, checked in this way. So if any of the prefix sum encountered inside the map, inside the set, then the iterator will not be pointing to the end position, and that particular position will not be equal to the end. The condition will be true, and as soon as we checked that this same prefix sum is encountered, therefore one subarray will be there, at least one subarray is there, because we have encountered this prefix sum once. So one subarray with sum 0 will be present. So therefore we have to just return this case, and also after doing this we have to insert that particular prefix sum inside the set. That prefix sum will be inserted inside the set. After doing this, uh, then we can return false at the end if we have not found any of the subarrays. So if any of the subarray is not found, at the end the execution will come here and just return false. Let me just take our input here. This is the input 4 2 5 is the size, and 4 2 minus 3 minus 3 1 6. Let me just run this. It is going to give us true because this is the subarray 2 minus 3 1 is one subarray with sum 0. So it is returning true, and I can also take 1 minus 2 1. Size is, let me just, so even it is true, I have for this particular condition assertion of 0 inside the set. It is going to give us true because the valid subarray which is starting from 0 index. Let me just, and it is going to give us false because we have not inserted 0, and 0 will not be found in the set at any false. Must insert this particular 0 in order to have the valid subarrays. And now let's see the time complexity and space complexity. Time complexity, for this we can see that this particular loop is running, and every value for every particular value inside the nums array, and because we are using the unordered set, so the data structures like this, like unordered set, unordered map, these are taking the constant operations for the lookup, for insertion, for finding, like this. So these are taking the constant operations for every value in the array, so therefore it is to take the linear time complexity. Now talking about the space complexity, there are different prefixes there, and in that case the space complexity will be the linear space of big O of n. Okay, so we are done with this particular problem, and along with its logic, implementation, the time and space complexity. Now let's get into the variant of the same problem. This is the another variant of it. uh, in the previous one we have to just check if subarray exists with the sum 0, at least one subarray we have to return true, but here we have to count all those subarrays with the 0 sum. Here the problem statement is, we are given with an integer array nums of size n. A subarray is a contiguous part of the array, and our task is to count the total number of subarrays whose sum is exactly equal to 0. We have to return the count at the end. This is the problem statement, and now let's just check in brief that how we have to solve this one. Again, this is let's just see that we are given with an input array, and we have to count for the subarrays with sum 0. Firstly, we will be started taking the prefix sum at every particular index. Okay, so if we are having the prefix sum at any particular index, we are having all the possibilities of the subarrays. So here, just suppose that this is the fourth index, and here we are having a prefix sum. And as I have just explained, that if we have particular prefix sum at this current index, so we have to check for the same prefix sum if it was encountered earlier. Okay. So if the same prefix sum was encountered earlier, therefore after that, let's suppose this is the zero index. If the same prefix sum was encountered, so from 1 to this 4 will be one subarray. Now if the same prefix sum was encountered two times, like one was at this zero index, let me call it as I1, and another was at one index, let me call it as I2. So therefore, if the same prefix sum was here, it means from one index till fourth index, the things were cancelled out and resulted as the sum 0. Again, if the same prefix sum was at 1 also, it means from 2 to 4 index, something has been cancelled, or it balanced out, which has resulted in the sum 0. So therefore, we have encountered two particular subarrays with the sum 0 if the prefix sum was encountered two times in the past. What it means is, if we are having a prefix sum at a particular index and we have checked that okay, this particular prefix sum has been encountered two times or three times or any number of times, that number of subarrays will be formed which will be ending at this particular index. This is the whole logic about this, and let me just go into this example and have a simple dry run. Okay, so this is the example on which I am going to perform a dry run. Because we have to store the prefix sum and along with its frequency, that how many times it came, I will also have to store the frequency. So for that I will be using an ordered map. So let me just take the unordered map here, and let me just give it a name. Let's say frequency map, because I will be storing the frequency of the prefix. And let me just maintain a prefix sum here in order to take the sum. uh, I will be to subarrays with zero sum. Then starting from zero index, I is pointing now at zero. One will be added firstly inside the prefix. When one is added, this one, and checking inside the this frequency map, we have seen one before. We have not seen, so therefore one will be added inside this map along with the one count. Some was encountered once till now. And now this I will be moving ahead minus one. When minus one is added inside this, it will become zero. And now when we will be checking for zero inside the map, so the same case which I have multiple times, that whenever we are getting any subarray, or we are checking for any zero, it means we are going to get a particular subarray which is starting from zero index. So for that we will have to insert zero. This time it will be count one, because that particular zero was a virtual prefix sum when we have not yet started with the sum. The but the prefix sum was zero in that case, and that was once only. One is added here. Now when we see this particular prefix sum is zero encountered inside the map or not, so yes, we have encountered, and that was one time. So therefore, because it was one time, so this count will be by one. Okay, because this particular this prefix sum, we can see here that this prefix sum was zero in this particular place when we have not started taking this. So it means from the zero till this one index, this will be a subarray. This is count is incremented for that. Now also this particular prefix sum is zero as of now. It means the prefix sum is 0 was encountered again at this one index, so we will have to increment the count for it. For 0 prefix sum, we will have to increment its count for 1, and it will now become 2. Okay, so what does this mean? One prefix sum was 0 once the prefix sum was 0 at this place when we have not started taking the sum, and 1 it is now at this index. Now let's move ahead. I moves ahead and it now adds 1 in the prefix. Prefix sum now becomes 1 again. Now it sees for 1 inside the map. 1 was encountered once. It means at this zero index. Because it was encountered at zero index, the same prefix sum 1 to 2, this subarray with sum 0. So now we can see here, if this was encountered once, so we can just increment the counts by 1 and it will now become 2. What we can say is, one subarray we have seen here with the sum 0, another subarray we have seen the sum with the sum 0 here. The count is 2 as of now. Because this prefix sum is 1, so we will be incrementing the count for this one prefix sum, and it will now become 2. Means for one time the prefix sum was equal to 1 in at the 0 index, and another time this particular same is at second index. And now this I will be moving ahead, and it will be now adding 1 in this. So when 1 is added, minus 1 is added, sorry, so it will now become 0. When 0 is added, we will be again checking inside the map that 0 has been encountered or not. So yes, 0 has been encountered, and it was encountered 2 times. One was at the point where we have not started taking the sum, another time when we were at this 1 index. Okay, so 0 was encountered 2 times, and because it was encountered 2 times, therefore 2 subarrays will be possible. Let me just give a brief here. This particular sum, this prefix sum was 0 at this point, so therefore one subarray will be formed here to here. It will be having a 0 sum. Let me just, one subarray will be formed here, the subarray, because one prefix sum was 0 in this place, and another prefix sum was 0 at this 1 index. Therefore one subarray will be from here to here. This is a very important one. Okay, we have seen two subarrays with the sum 0, because 2 has been encountered 2 times, so one at this position and one at this position, so 2 subarrays are formed. Therefore when added in this count, this 2 will be added and it will now become 4. So therefore at the end this 4 subarrays are there with the sum 0. Now when I is moved ahead, this particular process, we can see here count is having 4, therefore 4 number of subarrays with the sum 0 are available inside the input array. So now let's get into the implementation part of it. We have seen everything, whatever the cases are required, this particular logic. The implementation part for this is, let's come here, and firstly I will be taking the unordered map, and in this I will have to take the two parameters. One is for the prefix sum and another one is for the counting, is how many number of times that prefix sum came. That is for the frequency. Let me just name by this frequency. So this, and now the same thing which I have done, I will have to take this frequency of 0. Okay, if the prefix sum was 0, when we have not started taking the sum, that was 1 time. So this is we have to do, and now I will be taking the prefix sum. I will be initializing by 0, and I will also have to take the count variable, which I will be initializing by 0. And now I will be starting from the first value, means particular loop or auto val inside the nums, taking every value from the nums and adding inside the prefix sum. So prefix sum plus equal to this nums, sorry, val, and after taking the value inside the prefix sum, like adding the value inside the prefix sum, now I will be checking inside the frequency map that, using the find function, that if this particular prefix sum was encountered or not. This is the condition which we have to write, frequency dot end. So now this means is that if we have found that particular prefix sum inside the map, and now the iterator will be pointing, not be pointing at a particular end position, it will be pointing at some another position which will not be equal to end. So therefore this condition is true, and because it was found that the same prefix sum was found, now we will have to have the count of it. Okay, so now what we will be writing in this, in order to count the number of subarrays, we have seen in the explanation that the number of subarrays depends on the number of times the prefix sum occurred. So the number of times that prefix sum occurred in the past, that number of subarrays will be formed, which will be ending at that current index. For example, if we have seen here that when this I was at third index, we have seen that prefix sum was 0, and when we seen in the map, it was present 2 times. One was at the place where we have not started with taking the sum, and that was the prefix sum 0 at that place, and one was at the 1 index. Okay, so therefore the 2 times that same prefix sum 0 was occurring, because of which the two subarrays will be forming and ending at this third index. One subarray from 0 to 3 and another subarray from 2 to 3. Okay, so what it means is the number of times that prefix sum occurred inside the map, that number of subarrays will be formed, which will be ending at that current index. Okay, so if the prefix sum 0 was occurred 2 times, then 2 subarrays are formed, okay, which are ending at this last index or this third index. So that is the thing. So if we have to count this particular subarrays, so we have to see for the second parameter here. If this was encountered 2 times in the past, then 2 subarrays will count, and we will have to add this particular parameter in this count. What we have to write is count equal to count plus frequency of this prefix sum. Okay, is the second parameter. So what number is there? That number of subarrays which will be there will be added inside this count. And at the end, we have to just take this frequency of this prefix sum, and we will have to add one side it in order to count the in order to increment the frequency. It means if we have got a particular prefix sum, then we will have to insert that inside the map. Okay, every time whenever a particular prefix sum we get, we will have to insert that inside the map along with its frequency by incrementing its count to 1. Okay, so this is for it. And now at the end we have to just return this count, and which is give us the count of subarrays which are giving the sum 0. Let me just take this in 1 minus 1 1 minus size is 4, and 1 number of subarrays are giving the sum 0 4. Okay, so we can see here the number of subarrays with to sum are 4. One is this subarray, another one is this subarray, another one is this, and one is the entire array. These 4 subarrays are giving this. Again, for the time complexity, we can see here one loop is running, and for every value like insertion and lookup for searching, the unordered map takes the constant operation for constant time for every operation. So therefore the time complexity is O of n, and just in case if the collisions occur, then it can go to big O of n square, but that's very rare. uh, and checking for the space complexity, so space complexity is again there are distinct prefixes, then in that case they will be stored inside the unordered map, and that will lead to the big O of n space complex. This is all about this particular problem, and we'll meet in the another video with some more variants of the same pattern.